Let's take a look at a similar problem as the last video. In this case, we have a chain rule and a quotient rule. Notice we're still working with the same f and g functions, so that should make things a little easier for us in terms of computing things quickly. In this case, I see that I'm going to need a quotient rule because of this division, but also that my numerator and denominator require the chain rule. So if we let 2x plus 1 to the fifth power be f of x, and 3x minus 2 to the seventh power be g of x, then we can look at h of x as the quotient of f over g. And we know that the quotient rule for this derivative says we need f prime times g minus f times g prime, all divided by g squared. Looking at this, we can see all the derivatives we need to compute. So we need f prime and we need g prime. F prime is the derivative of 2x plus 1 to the fifth power. That will look like 5 times 2x plus 1 to the fourth times 2. G prime is the derivative of 3x minus 2 to the seventh, which looks like 7 times 3x minus 2 to the sixth times 3, which is 21 times 3x minus 2 to the sixth. And each one of those is going to be plugged into our quotient rule roadmap. So to save space, f prime, I'll write that as 10 times 2x plus 1 to the fourth. G prime, I'll write that as 21 times 3x minus 2 to the sixth. And then we don't need this anymore. Our next step is then to just replace g and f according to what we found when we broke open h of x. So that would look like plugging in 3x minus 2 to the seventh for g, plugging in 2x plus 1 to the fifth for f, and then dividing all of that by g squared. Now, g is already a binomial raised to a power. So we're raising a power to a power here. That's like saying 7 raised to the, an exponent of 7 raised to a second power, that we would multiply those two numbers. So in our denominator, we really have that factor to the 14th power. Now, here's where the messy algebra comes in. We want to factor the best we can. I can see that in the numerator I have two terms, and both terms have some common factors. They both have 2x plus 1, and they have 4 of them at least in common. I also can see that those two terms in the numerator have a common factor of 3x minus 2. We have 7 in the first term, 6 in the second, so I know that they both have at least 6 in common. If I factor off those common factors, then I have some factors left behind from each term. In the first term, I have a 10 left behind and one of the 3x minus 2 terms. In the second term, I have a 2x plus 1 left behind, 21 is left behind, and that's it. And then, of course, we need to copy over our denominator, which hasn't changed. Now, writing it like this, I can see that there's common factors in the numerator and the denominator. I have 6 of the 3x minus 2's on top and 14 of them on bottom. So what I can do is divide all of them off of the top and reduce 14 by 6. Leaving 8 in the denominator as my exponent. And then in the numerator, I can distribute my product, So that would look like 2x plus 1 to the 4th times, I've got 30x minus 20 minus 42x minus 21. So that's going to look like negative 12x minus 41. And then copy over our denominator. And that's our derivative, h prime of x. Now again, remember that at this point we had finished the calculus. It's the rest that's probably the hard part, the algebra. Take your time on the algebra, write your steps out one by one. That way, if you do make a mistake, you can find out where it was, and you can make the corrections from there forward.